Hi everyone, I thought we'd try a video this week. So as you can see on the board, we're going to look at the buffer stock diagram. It's theme 4, it's an intervention method, but you might be surprised, you can see on the board here we've got a micro diagram. Now one of the bits of information we always tell you is don't mix your micro and your macro. There's a reason why we've got a micro diagram. This is to look at volatile prices, and it's often used in countries where we've got commodities that the country is heavily reliant on, often primary products. So although the industry, as we can see it here, is not the whole economy, it's a large proportion of it. So any intervention in the industry will have a big impact on the economy as a whole. So what have we got here? Well, we've got a standard supply and demand diagram, but as we say, we've got a volatile product here, and often this is due to climatic conditions, it's due to supply itself being volatile, and as supply moves, it's going to change that equilibrium quite significantly. So how does it work? Well, we've got an equilibrium price and quantity here, and if the price stayed at P0 and the output stayed at Q0, we'd be absolutely fine. However, it doesn't stay there. What we'll often get is this very, very low inelastic supply, we'll call that S0, Q0, or an incredibly high supply, S1, Q1. Now, we've got two problems here. If we get a really low output, we're going to get an equilibrium price which is incredibly high. We'll call that P0 there. If we get S1, we're going to get an equilibrium price which is incredibly low over here. Now that's not good for either consumers if prices go really high, it's not good for producers if prices go really low. The price is volatile, it's constantly moving, and this might be week to week, month to month, year to year. So what does the state do? What could they do? Well, they could use something called a buffer stock, and this is what we're going to look at here. And the overriding aim of this is to reduce this volatility. So in theme 1 we did minimum maximum price, we're going to do something similar here. So what we're going to say is we're going to pick a price, here's my equilibrium, I'm happy with that one, happy with P0. I'm going to have a price maybe here. And that is going to be my maximum price. I'm going to have another price here, which is my minimum price. Meaning that the price, I'm only going to allow it to be volatile within that region there. Now you could close that even more, but you'll see in a minute why that can make things even trickier. So I've got this diagram. It now looks a bit of a mess, but let's start interpreting what we've got here. So we've got this price range. If you look here, if the price is P0 or actually anywhere between the two, there is no intervention at all needed. So although the diagram is here, nothing happens. We're only going to see some kind of intervention by the state if that price range moves out of the P-min to P-max range. Well, let's take an example. Let's say that we've got rice here and we have a really poor harvest of rice and we get S0. Well, if we get S0, we've got a problem here because look at our equilibrium. Our equilibrium is up here, meaning that we've got a very low output of Q0, which is below the minimum that we would like, our Q min, and we'll just add on Q max. And we've got a price all the way up here, whereas we'd like to be here. So that's a problem for us. If we look on the other side and we have a really, really strong production, which is not a bad thing, but maybe that drives the price down too low, then we're going to be here. We've got Q0 here. And what have we got? Well, we've got this overproduction, and actually we want to get it back in that range. So what can the state do? Well, they can do a couple of things. First of all, if we get S1 and our equilibrium price is below P-min, so we can see there, P1, well, the state can buy up the difference. So you can see here, if supply was here, then we'd have a price of P-min, but it's not. So what does the state do? Well, the state buys, I'll put buy there, will buy from Q0, to Q, let's call that Q3. They will buy that amount up. And what that'll do is move the price because it artificially reduces the supply, it will reduce the price, increase the price up to P min. So we're still at the minimum, but we are back within our range. The government's got to store this. This is a problem, but we'll talk about this in a second. Flip side, if you've got a really poor output and you've got a price up at P0, far too high, well, what can they do? Well, they've bought it all here. Well, the government can put that onto the market so they can sell. So we can have sell there. So this system works in a way that the government is buying and the government is selling to enable this price to stay within the boundary here. But there are problems. There are what we would call evaluation points in economics. First problem is, how do you decide the width of this P min to P max? The further these two are apart, the easier it is to control. But if 99 times out of 100 you're within the two, actually you're not going to do any intervention at all. You're not going to stop it being volatile. If you make it too close, well, actually you're constantly intervening in the market, which can make things quite tricky, especially admin costs, for example. What else? Well, we're looking at developing economies here. If you're guaranteeing a price to a producer, well, maybe they will move some of their land or more of their land for that good. What might happen? Well, we might have this unexpected consequences where supply increases dramatically over to the right because firms can make money because they're guaranteed the P min that we've got here on the board. But there's also further problems. What about if we have lots of years in a row with high supply? The government's buying every year. Number one, that includes the cost. Number two, what do they do with it? They've got to store it. How perishable is it? Well, this kind of system doesn't work with a perishable good, but nothing lasts forever. So how do they keep everything within here? And these are problems of the buffer stock. It's quite difficult to find examples where it's worked effectively. You will find some, for example, Indonesian rice farms, but other than that, there's very, very few. Taken on face value, the diagram looks fiddly, and it is a bit of a nuisance to draw, but once you've got it and you start breaking it down and interpreting it, you'll be absolutely fine. Key thing with this, buffer stock diagram is used to reduce volatility in a market, reduce the volatility of the price, which gives the firm, the industry, and the economy potentially more confidence.